But they're not cooperating with you.
Move on.
Frustrated.
Can I put it back in the water? It's already back in the water. We put it back in the water because we want it to start at the same temperature. Yeah, so like we put it under the heat lamp and it gets really hot, so we put it in cold water. We'll barely go to that. See? Not yet. No, about 37 right here. Zach, run away. Zach, you run away. You take the clock. This is the clock. Thanks. And no, I started at 2. We're gonna put different colored papers and seeing the temperatures.
And what color?
And we are surprisingly, our prediction was the dark blue paper was 69, the red was 68, the green was 67, the black was 66, and the white was 71. And our prediction was the darker the color, the more heat it will have, and the lighter the color, because light color is less black and the darker color is absorbed. But from and we put it on the below the heater lamp at the same distance and the same time.
Thank you. My question is, how can you prove that your results are accurate?
Right.
You're scientists.
Mrs. Miller videotaped it.
All that videotape is going to do is prove that it worked once.
We did 3 times.
And you found the same results all 3 times.
Well, not really.
Okay.
The temperature started always at 60 degrees, and then for black. No, don't read the dark blue one. Okay. For black. For black, for our first trial was 68 degrees. Second trial was 66 degrees, and third trial is 68 degrees.
Okay, so I don't understand why you're getting different results, and you need to figure out why you're getting different results. You are scientists, and if your experiment has no variable other than the color of the paper, then nothing should change from trial to trial. And yet, your trials were different. So I want you to think about what could have happened that caused a temperature change.
Maybe our timing.
Maybe.
Because we actually timed it ourselves, and timing probably right.
So a timer would help you better? Where do we have a timer? Oh, yes, but you can also get one off my desk. There's a timer on my desk.
Okay, are we ready? Trial number 1. Are you ready to record? Okay, I would say that was passed. It's gone off to the side, so I would say about 72 inches. Okay. Trial number 2. And let's see if we straighten this out. Trial number 2. No. Wait a second. Wouldn't that be getting a variable?
All right.
And how many trials do we want in order to eliminate uncertainty? A minimum of 3. Don't block it. Where's it stopping? Woo!
117 inches.
117. Bring it back, please. That's okay. So maybe we need to move that too, right? Okay. Yeah. Trial 3. Here it goes. Why is it going that way all of a sudden? I wonder. Could this have been going that way? Yep, it is. Sure it's at 15. Okay. And
OMG. What do you have first? We'll do yellow first. Put it on high water pressure. Put it on high water pressure.
Careful not to get the light bulb wet. You've got to get the light bulb wet.
Yes.
So be careful with the splashing.
There's a light bulb lighting.
No, it's the other way.
Wait, guys, pause it. Guys, switch it the other way. Like, turn it. Like, turn it like this. Turn this thingy jigger the other way so it flashes that way and not on the light bulb. Lighting. Exactly.
Trial and error on the
My hair is going to pop up right now.
You know what I would be? I would be going home and in bed thinking, what can I do tomorrow?
Exactly. That's exactly what it looks like. But you know what? If you keep your sense of humor about it, that's very cool. They're calibrating
They're using a pulley.
Okay. Where are we going to place this? Billy, my buddy, where are we going to place this? Remember, we have to measure, right? So, okay, so let's...
What are we doing?
Remember, the ramp to remain the same length, and we're sending the ball down here, correct? So let's move that out of the way. Okay, this is going to start at this line, correct? Okay, and we want to see how far. We need, first of all, since we've changed this variable, we need to also put the fan so that it's flowing this way, right?
Where's the ball? Where's the ball?
Okay. Do you have the ball? Where's the ball?
You got another ball?
So, we can do it 3 ways. Look at this. No wind. No wind. But the same force, right?
Oh, yeah.
Wind.
Yeah, and without
With no force pushing it, right? And wind in the opposite direction and wind in the side. Okay.
Jeremy.
Okay, so what are we going to do?
But then it's got
What, is that helping us to measure it? And could we then reverse it and have it flow back that way? Okay, that's not possible. All of this is possible. You could also place it here and measure the distance from there. But first we have to do what? No wind. Then we have to do applying the variable or applying the wind. That's a variable, right? You're getting way past Mrs. Jones. Okay, so no wind. That's the way to release. Are you ready? This took us a
Well, I think this will too. We're working on it.
Okay. Where does it stop?
We need to go to lunch.
I know.
We really do.
Let's first, can I have this,
Okay, so my question to you is, how'd you get rid of the human variable? What's a thingy? A pulley, can I see? So what happens when you let the string go? Well, let me see that work.
Ooh, turbine. Hi, turbine.
Okay, so you let go of the string.
What do you guys do?
Here we go.
Okay, so you let go of the string and it drops. Okay, how high above the... Okay, let's see what happens.
Yeah, we did
Okay, so what just happened?
It went backwards.
Okay. And why do you think it went... Come over there. Why do you think it went backwards? Why did it go backwards?
Because it was too far back.
I don't think that's why.
Maybe because it has to go right after, not like right there. Right there.
Okay, so you want to try that?
Yeah.
Okay, you have to tell Billy and Nick to move.
Billy, can you move, please?
You two go to the other side.
Yes, it's balanced. It needs to be like right on top. Maybe like right next to it so I can just lean it on. Okay, so it's like right here. Good. Wait, we have to...
So, right, so I want to know, go over there so I can actually videotape you. I want to know why this is happening. What's going on with that lever every time you drop the weight on it?
It moves backwards.
Okay, so we have to find a way to keep the lever from moving. You don't want the lever to move off the fulcrum. You want it adhered to the fulcrum. Do you understand what I'm saying? Do you understand what I'm saying? Do you understand, Zach, what I'm talking about? Like, where do we have to have this still?
In the middle? Right in the middle.
And it needs to stay there. And what's happening is you're dropping this and it's lifting up.
What about a piece of tape?
We could try that. If you put a piece of tape, will it still move?
I think so.
You need to try. Keep working on it. So I'm back again with the Mechanical Energy group, and we're trying, they have quite a setup here now to drop that toy.
Yeah, how do we get rid of me holding the ruler?
Yeah, look, I see a human. I want you to get rid of that extra bulb. No, I didn't say take the bulb out. Get rid of that part of the circuit.
Oh, what part of the circuit? Hold on. Oh, like one of these.
Now you have to put the nail in.
What?
Now put the nail in and see what's going on. Can you do something to the thermometer so that it will absorb more heat?
We can bring it much closer, like we can bring it this closer.
You can try. But you're holding it and you gotta get...
I think that you should instead of that, grab some more aluminum foil.
Around one.
Can I tell you something about that lamp?
Let's try.
See that it moves the lamp? That is if it Zachary, come over here and take there's 2 chips. You have to record each of them. That totally does not count.
What'd you learn today about being a scientist?
That you feel a lot of times, a lot of times you do.
And what'd you learn about energy?
Well, what kind?
Well, I don't know. Tell me a kind.
Well, for the one I just did, like when we tried different wires to see for the circuit, I think it's called nitro, that kind of wire. It doesn't really work with the circuit that when we tried it.
So we're not getting much energy through it?
Yeah, but the copper does.
So copper is a good conductor of electric energy?
Yeah.
Thank you. So what did you learn about being a scientist today?
Well, sometimes you're probably going to fail and fail and fail, but eventually you'll get what you're looking for, the information.
So is this something you think you'd want to do?
Definitely, because I was doing the light, and then at first, like, we kind of like messed up, like the timing didn't go so well, so we had to restart it all, which was annoying, but like it actually worked.
So you liked when you finally got it?
Yeah, when you finally get it, you feel like, yes, I'm done with it. I get to move on to the next thing, and it just, like, you feel really good.
Excellent. Thank